Picture this, a swirling cosmic giant, twice the size of our Milky Way, floating silently in the void. The Andromeda Galaxy, our closest galactic neighbor, isn't just a pretty spiral in the night sky. It's a treasure chest of cosmic oddities that defy everything we think we know about the universe. Right now, as you watch this, strange forces are at work there. Phenomena so bizarre they've left astronomers scratching their heads. Some of these mysteries might rewrite the rules of physics. Others hint at forces we can't even begin to understand. From stars racing fast enough to escape a galaxy to ghostly spiral arms invisible to human eyes, Andromeda is hiding 25 jaw-dropping secrets. Imagine entire star clusters vanishing without a trace. Picture black holes flaring violently for no apparent reason. Think about a cosmic mirror effect that eerily links Andromeda to our own Milky Way. These aren't science fiction, these are real, unresolved puzzles happening right now in our cosmic backyard. Scientists have spent decades unraveling Andromeda's riddles, and yet the deeper we look, the more questions we find. What's causing these strange events? Could some of them hint at entirely new cosmic laws? Or dare we say it, could there be something even more unexpected at play? Strap in, because we're about to dive into 25 of the most mind-bending phenomena in Andromeda, and by the end, you'll never look at the night sky the same way again. Ready to explore the galaxy's greatest mysteries? Let's begin. Now, let's unpack the first jaw-dropping mystery, the Andromeda Paradox. Imagine a galaxy spinning gracefully, its stars and gas moving in harmony. Except in Andromeda, some regions seem to break all the rules. Astronomers have spotted sections near its outer edges rotating in the opposite direction to the rest of the galaxy, like a cosmic dance where a few partners suddenly decide to waltz backward. This shouldn't happen. According to everything we know about galactic mechanics, a galaxy's rotation should be smooth and unified, governed by gravity's relentless pull. So why is Andromeda flouting the rules? One leading theory points to galactic collisions. Picture this: billions of years ago, a smaller galaxy may have smashed into Andromeda, stirring its outer regions like a spoon in coffee. The gravitational chaos could have twisted some stars and gas into reverse motion, leaving behind these rebellious swirls. Another idea suggests that dark matter, the invisible glue holding galaxies together, might be distributed unevenly in Andromeda, creating strange gravitational eddies that tug certain regions backward. But here's the catch: neither explanation fully accounts for the sheer scale of these counter-rotating zones. What makes this paradox truly mind-bending is how it challenges our cosmic playbook. Galaxies aren't supposed to have backward patches. Their rotation is a fundamental fingerprint of how they form. If gravity alone can't explain this, could there be unknown forces at work? Some researchers even speculate that Andromeda's odd rotation might hint at flaws in our understanding of gravity itself, echoing the puzzles that led to dark matter's discovery. And here's the kicker: this isn't just a curiosity. The Andromeda Paradox forces us to rethink how galaxies evolve. If collisions or dark matter can twist a galaxy's motion so dramatically, what does that mean for other spirals, including our Milky Way? As telescopes peer deeper into Andromeda's chaos, one thing's clear: the universe loves throwing curveballs, and this galaxy is playing hardball. Next up, we'll dive into an even bigger head-scratcher: the case of Andromeda's missing dark matter halo. Trust me, it gets weirder. Now, let's shift gears to something even more puzzling: Andromeda's missing dark matter halo. Dark matter is the universe's invisible scaffolding, the unseen force that shapes galaxies and holds them together. Typically, massive galaxies like Andromeda should be wrapped in a thick cocoon of this mysterious substance, far outweighing their visible stars and gas. But here's the twist: Andromeda's dark matter halo is shockingly faint, almost as if someone forgot to pack half the glue needed to keep it intact. to appreciate how strange this is, let's compare it to our own Milky Way. Our galaxy's dark matter halo is robust, extending far beyond its sparkling disk, its gravitational grip keeping everything from stars to entire star clusters in check. Scientists estimate that dark matter makes up roughly 90% of the Milky Way's total mass, but Andromeda, its halo, is a ghostly wisp by comparison. Measurements suggest it has only 30 to 50% of the dark matter expected for a galaxy of its size. That's like finding a skyscraper built with half the steel it needs, yet somehow still standing. So what's going on? One possibility is that Andromeda's violent past stripped away much of its dark matter. Picture this: over billions of years, as smaller galaxies collided with Andromeda, gravitational tugs of war could have ripped away chunks of its dark matter halo, scattering it into the void. Another theory suggests that dark matter isn't distributed the way we think. Maybe it clumps unevenly, leaving some galaxies, like Andromeda, with far less than they should have. And this is the real curveball: could our understanding of dark matter itself be flawed? This isn't just an academic puzzle. Dark matter is the backbone of galaxy formation. If Andromeda defies the rules, it forces us to ask, do we need to rewrite the cosmic playbook? Some researchers are even exploring radical alternatives, like modified gravity theories, to explain these anomalies. But every new observation deepens the mystery. For instance, recent studies hint that Andromeda's faint halo might be linked to its unusual satellite galaxies, or lack thereof, raising even more questions about how dark matter shapes galactic neighborhoods. What makes this enigma so thrilling is that it's not just about Andromeda. If our closest galactic neighbor breaks the mold, what does that say about the universe's hidden rules? Every answer we chase seems to lead to two new questions, and as we'll see next, Andromeda has even more surprises up its sleeve, like a colossal, unexplained ring of radio waves wrapping around it. Buckle up, the weirdness is just getting started. Just when you thought Andromeda couldn't get any stranger, it throws us another cosmic curveball, a titanic ring of radio waves encircling the galaxy like a ghostly halo. This vast structure, stretching over tens of thousands of light years, isn't just unusual, it's downright baffling. Most galactic features glow in visible light or X-rays, but this one broadcasts its presence in radio frequencies, pulsing with energy we can't easily explain. So what could create such an enormous radio ring? One leading theory points to a cataclysmic chain reaction of supernova exploding stars whose shockwaves might have carved out this colossal bubble. Picture a cosmic domino effect. As generations of massive stars died in explosions, their combined energy could have sculpted this faint, glowing structure over millions of years. But here's the catch. Even the most powerful supernova remnants we've observed elsewhere don't form rings this large or symmetrical. It's like finding a single firework that lit up an entire city. Then there's the wilder possibility. Could we be looking at the aftermath of a supermassive black hole's tantrum? Black holes sometimes belch out jets of energy, but these usually shoot in opposite directions like cosmic blowtorches. For one to create a perfect planet-sized ring would require physics we've never seen before. Some researchers suggest it might trace the edges of an ancient jet that's since faded, leaving behind this eerie imprint. But again, the sheer scale defies explanation. Of course, whenever science hits a wall, imaginations run wild. Could this be evidence of something unnatural? The ring's precise shape has fueled speculation about alien megastructures, hypothetical constructs like Dyson spheres or colossal energy harvesters. While there's no concrete evidence to support this, the idea taps into a thrilling question. Would we even recognize artificial phenomena if we saw them in deep space? Most scientists dismiss this as science fiction, but the mystery lingers precisely because we lack a clear natural explanation. What makes this radio ring truly exceptional is its solitude. Similar structures in other galaxies usually come in pairs or clusters, often tied to visible features like star-forming regions. Andromeda's ring, though, stands alone with no obvious source. Recent studies using advanced radio telescopes reveal it's also remarkably uniform. No kinks, no warps, just a smooth, giant loop whispering across the cosmos. This enigma isn't just about solving a puzzle. It challenges our assumptions about how energy moves through galaxies. If supernova or black holes can't fully account for it, are we missing a fundamental piece of galactic physics? Every time we train our telescopes on Andromeda, it serves up another lesson. The universe is far weirder than our textbooks suggest, and as we'll soon see, the surprises don't stop there. Up next, an anomaly that defies the very laws of stellar evolution: clusters of young, blue stars where they absolutely shouldn't be. Now, just as we're trying to make sense of Andromeda's bizarre radio ring, the galaxy confronts us with yet another head-scratcher: a population of youthful, blue stars glowing defiantly in its outermost reaches. This isn't just unusual, it's like finding a kindergarten in a retirement home. Galactic halos, those sparse outer regions of galaxies, are supposed to be cosmic graveyards home to ancient red stars that formed billions of years ago. But Andromeda's halo is dotted with vibrant blue clusters burning hot and young where they simply shouldn't exist. So what's going on? These blue stragglers, as they're called, are massive stars that burn bright and die young, often in just tens of millions of years. Normally, they're found in star-forming regions within a galaxy's spiral arms where gas and dust are plentiful. But out in the halo, that's like finding a lush rainforest in the middle of a desert. The leading explanation is as dramatic as it is violent: Andromeda's turbulent past. Astronomers suspect these stars are cosmic souvenirs from Andromeda's long history of galactic cannibalism. Over billions of years, it's likely gobbled up smaller dwarf galaxies, tearing them apart and scattering their stars across its outskirts. During these collisions, pockets of gas could have been compressed, triggering sudden bursts of star formation far from the galaxy's core. Imagine a cosmic wrecking ball smashing through a gas cloud, leaving behind glittering blue stars in its wake. But here's the twist: some of these clusters aren't just young, they're too young. Their chemistry suggests they formed in near isolation, with metal contents that don't match typical dwarf galaxy debris. This raises even wilder possibilities. Could Andromeda's halo still hold hidden reservoirs of gas, quietly spawning new stars where we thought it impossible? Or are we witnessing the aftermath of an entirely different kind of collision? Perhaps a direct hit between two gas-rich galaxies that left behind these stellar oddities. The implications are profound. If star formation can happen in galactic halos, it challenges our entire understanding of how galaxies evolve. It suggests that the quiet outer fringes of galaxies might be far more dynamic than we ever imagined. Andromeda, it seems, is forcing us to rewrite the rules again, but the mystery doesn't end there. These blue clusters are also strangely clustered themselves, hinting at yet another layer of violence. Some researchers propose they might trace the orbits of long-dead dwarf galaxies. Their stellar remains still marking paths across the sky like cosmic fingerprints. Others wonder if gravitational tides from Andromeda's central black hole could have flung them outward in a celestial slingshot. One thing's for certain: these blue star clusters aren't just anomalies. They're smoking guns, evidence of a galaxy that's lived a far more chaotic life than its serene spiral appearance suggests. And as we peel back the layers, we're left with a tantalizing question. What other secrets is Andromeda's halo hiding? The answer might just lie in our next phenomenon: a series of erratic, high-energy X-ray bursts erupting from the galaxy's core with no discernible pattern. Now, just as we're puzzling over Andromeda's rebellious blue stars, the galaxy throws another curveball our way. This time from its very heart, deep within its core, astronomers have detected violent, unpredictable bursts of X-ray energy erupting without warning. These aren't steady flickers or rhythmic pulses. They're chaotic, high-energy explosions that defy patterns, appearing and vanishing like cosmic Morse code with no clear message. X-ray bursts are nothing new in space. We've seen them in our own Milky Way, often tied to neutron stars or black holes siphoning material from a nearby companion star. But Andromeda's bursts are different. They're brighter, more erratic, and frustratingly inconsistent. Some flare up in seconds, then vanish for years. Others flicker intermittently as if something or someone is toggling a cosmic switch at random. This irregularity has astronomers scratching their heads. The prime suspect, Andromeda's supermassive black hole, a behemoth with a mass tens of millions of times greater than our Sun. Normally, black holes emit steady X-rays as they feed on surrounding gas and stars. But Andromeda seems to be dining in fits and starts. One theory suggests that stray stars or gas clouds are falling into it sporadically, creating bursts when they're torn apart. Imagine tossing logs into a bonfire one by one. Each impact produces a sudden flare. But here's the catch: the timing doesn't always add up. Some bursts occur when no visible material is near the black hole, leaving researchers wondering if something invisible, like dark matter, could be fueling them. Then there's the neutron star possibility. These ultra-dense stellar corpses, no larger than a city but weighing more than the Sun, can unleash colossal X-ray flares if they collide or pull material from a neighbor. In Andromeda, neutron stars could be lurking in dense clusters near the core, occasionally interacting violently. But again, the irregularity is a problem. Neutron star outbursts usually follow rough timetables based on their orbits. Andromeda's bursts play by no such rules. Even stranger, some bursts appear to come from empty regions, places with no known black holes, neutron stars, or even visible stars. This has led to more exotic theories. Could these be signs of primordial black holes, hypothetical ancient objects left over from the Big Bang? Or perhaps something even weirder, like Magneta's neutron stars with magnetic fields so strong they warp the fabric of space around them, flaring up unpredictably. The mystery deepens when we compare Andromeda's bursts to those in our own galaxy. The Milky Way's central black hole is relatively quiet with only occasional flickers. Andromeda's hyperactivity suggests its core is far more dynamic, or that we're witnessing a rare phase in its life. It's like comparing a calm pond to a boiling geyser. What's clear is that these bursts are more than just cosmic fireworks. They're clues hinting at invisible forces, extreme physics, and perhaps even new celestial phenomena we haven't discovered yet. Every erratic pulse challenges our models of how galaxies behave, pushing us to rethink what lurks in their hearts. And as we piece together the puzzle, one thing becomes certain. Andromeda's core is anything but sleepy. It's a cauldron of chaos, and we're only beginning to understand its recipe. But the surprises don't stop there. Beyond the bursts, Andromeda holds another enigma, a hidden structure lurking in plain sight, visible only to those who know where to look. Just when you thought Andromeda couldn't get any stranger, it pulls another trick out of its cosmic sleeve, this time hiding entire spiral arms in plain sight. While the galaxy's iconic swirling structure is visible in ordinary light, astronomers have discovered ghostly arms that only reveal themselves under the gaze of infrared and radio telescopes. These hidden tendrils of gas and dust weave through the galaxy like invisible threads, hinting at a violent past we're only beginning to unravel. Most spiral galaxies, including our Milky Way, have arms glowing with young, hot stars. But Andromeda's invisible arms are different. They're faint, fragmented, and packed with cold gas and ancient dust, making them detectable only at longer wavelengths. Imagine trying to see a shadow in a pitch-black room until you switch to night vision. It's simply not there. That's the challenge with these structures. They're part of Andromeda's skeleton, remnants of events that reshaped the galaxy long ago. The leading theory, a galactic collision. spiral arms don't just vanish or appear without reason. Their ghostly presence suggests Andromeda once devoured a smaller galaxy, sending ripples through its disk like a stone tossed into a pond. Over time, these ripples settled into the faint arms we see today. The evidence is in the details. The gas in these arms moves differently than the rest of the galaxy, as if still carrying the momentum of that ancient crash. Some regions are oddly rich in metals, a telltale sign of stars born from the debris of that merger. It's like finding footprints in the sand long after the tide has washed them away. But here's where it gets even more intriguing. These hidden arms aren't just relics, they're active. Radio observations show pockets of star formation bubbling up within them, suggesting the gas is still settling, still stirring. It's as if Andromeda's digestion of that past meal isn't quite finished, and the scale is staggering. Some of these arms stretch tens of thousands of light years, dwarfing even the brightest visible structures in the galaxy. What does this mean for Andromeda's evolution? For one, it confirms that the galaxy grew by consuming others, a violent process we once thought was rare. But Andromeda's multiple hidden arms imply it's happened more than once. Each set of arms could be a fossilized record of a different merger, a different chapter in its history. It's like peeling back layers of an onion, each revealing a new era of cosmic drama. Compare this to the Milky Way and the contrast is striking. Our galaxy has its own faint structures, but nothing as pronounced or as complex as Andromeda's. This suggests Andromeda has been far more active, far more hungry in its past. Some astronomers even speculate that these hidden arms are a preview of our own fate, a glimpse of what might happen when the Milky Way and Andromeda collide in a few billion years. Will our galaxy leave behind similar ghosts? Only time will tell. For now, these invisible arms are a reminder of how much we don't see with our eyes alone. They challenge us to look deeper, to question what else might be hiding in the darkness. And as telescopes grow more advanced, who knows what other secrets Andromeda has yet to surrender. One thing's certain: the more we uncover, the stranger this galactic neighbor becomes. And speaking of strangeness, buckle up, because next we're diving into stars moving so fast they could escape Andromeda altogether. Now, just when you thought Andromeda had shown us all its tricks, it flings stars across space like cosmic slingshots. These aren't just fast-moving stars, they're hypervelocity stars, racing so quickly they could break free from the galaxy's gravitational grip entirely. Imagine a star moving at millions of miles per hour, fast enough to cross the distance between Earth and the Moon in mere minutes. That's the kind of speed we're talking about here. So where do these stellar speedsters come from? The leading suspect is Andromeda's supermassive black hole, lurking at its center. When a binary star system, two stars orbiting each other, wanders too close to this cosmic monster, things get chaotic. The black hole's immense gravity can tear the pair apart, capturing one star while violently ejecting the other at unimaginable speeds. It's like cracking a whip. One end stays in your hand while the other lashes out with incredible force. But here's the twist. Not all hypervelocity stars in Andromeda fit this explanation. Some appear to originate far from the galaxy's core, suggesting alternative mechanisms at play. Could they be survivors of dwarf galaxies torn apart by Andromeda's gravity, flung outward like debris from a car crash? Or perhaps they're the product of supernova explosions, where a dying star's violent death kick propels its companion into the void. The answer isn't clear yet, and that's what makes these stars so fascinating. What's truly mind-bending is how these rogue stars challenge our understanding of stellar dynamics. Normally, stars move at predictable speeds, bound by the gravitational rules of their galaxy. But hypervelocity stars break those rules. Their existence forces us to reconsider how energy and momentum work on galactic scales. Some of these stars might even become intergalactic travelers, drifting through the emptiness between galaxies for eternity. Andromeda's hypervelocity stars also offer clues about its past. Their trajectories could reveal ancient collisions or disruptions we've yet to uncover. By tracking their paths, astronomers get a snapshot of the galaxy's gravitational history, like following breadcrumbs back to long-forgotten cosmic events. Compared to the Milky Way, Andromeda seems to host more of these runaway stars, hinting at a more turbulent past filled with close encounters and violent interactions. One star in particular stands out, nicknamed Andromeda's Arrow. It's racing toward the galaxy's outskirts at speeds that defy explanation. Some researchers suspect it might not be from Andromeda at all. It could be an invader from another galaxy entirely, captured during a long-ago close encounter. If true, it would mean this star has already survived one galactic escape, only to attempt another. What's next for these stellar fugitives? Some may eventually slow down, succumbing to the galaxy's pull. Others could vanish into intergalactic space, becoming lone wanderers in the cosmic dark. Either way, their existence reminds us that galaxies aren't static. They're dynamic, ever-changing systems where stars can be born, destroyed, or even exiled. Speaking of exiles, our next mystery takes us to the very heart of Andromeda, where not one but two cores lurk in the shadows. Now, just when you thought Andromeda couldn't get any stranger, we stumble upon its most baffling secret, yet a galactic core that shouldn't exist. Deep in the heart of this colossal spiral, astronomers found not one, but two bright nuclei lurking side by side, like cosmic twins sharing a single throne. Most galaxies, including our Milky Way, have a single supermassive black hole anchoring their center. But Andromeda defies expectations with this double act. The primary nucleus is massive, weighing in at around 100 million times the mass of our Sun, while its smaller companion sits just 10 light-years away, practically next door in cosmic terms. What's going on here? One leading theory suggests this duality is the aftermath of a galactic merger. Billions of years ago, Andromeda might have cannibalized a smaller galaxy, and instead of the two black holes merging immediately, they've been locked in a slow gravitational dance. This would explain why the smaller nucleus appears slightly off-center, as if it's still settling into place. Over time, the pair should spiral closer, eventually colliding in an event so violent it would ripple spacetime itself. But until then, they're a rare snapshot of a middle stage in galactic evolution, one we almost never get to see. Yet there's a twist. Some researchers argue the second core might not be a black hole at all. Infrared observations reveal it's unusually rich in young, hot stars packed impossibly close together. This could be a dense stellar cluster, a relic of star formation triggered during a past collision. If true, it means we're seeing not two black holes, but a monster and its glittering entourage, a black hole surrounded by a swarm of stars born from chaos. Why does this matter? Because Andromeda's double nucleus challenges our models of how galaxies grow. If mergers leave behind lingering cores like this, it implies galaxies are far messier than we thought, with black holes taking eons to fully unite. It also raises questions about the Milky Way's future. When our galaxy collides with Andromeda in 4 billion years, could we end up with a dual core of our own? The strangest detail, this double structure is nearly unique. Only a handful of galaxies show similar features, making Andromeda a crucial laboratory for understanding how black holes interact. Every observation peels back another layer of mystery, like why the smaller nucleus orbits at an odd angle, or why it's brighter in certain wavelengths. Each clue hints at a violent past we're only beginning to reconstruct, and here's the kicker. If the second core is a black hole, it's unusually quiet. Most black holes this size would devour nearby gas, unleashing torrents of radiation. Yet this one seems dormant, as if it's biding its time. Could it be starved of fuel, or is something else suppressing its appetite? The answer might rewrite how we understand black hole behavior in merged galaxies. One thing's certain, this duality isn't just a curiosity. It's a window into Andromeda's turbulent history, revealing how galaxies stitch themselves together over cosmic time. And as we'll soon see, this isn't the only surprise hiding in Andromeda's shadowy outskirts. Now, shifting our gaze to the outskirts of Andromeda, we encounter another puzzle that defies expectations: the case of the missing dwarf galaxies. Theory predicts that a galaxy as massive as Andromeda should be surrounded by a bustling entourage of smaller satellite galaxies, perhaps even hundreds of them. But when astronomers tally them up, the numbers fall startlingly short. Where are all these phantom satellites hiding? One compelling explanation points to dark matter, the invisible glue holding galaxies together. Current models suggest that dark matter should clump into countless small halos, each potentially hosting a dwarf galaxy. But if those halos lack enough regular matter to form stars, they'd remain invisible to our telescopes. This could mean Andromeda's satellites aren't missing at all, they're just too dark to see. Supporting this idea, some ultra-faint dwarfs have been detected around Andromeda, barely luminous yet rich in dark matter. These ghostly galaxies might be the tip of an unseen iceberg, hinting at a hidden population lurking in the shadows. Yet not everyone is convinced. Alternative theories argue our understanding of satellite formation might be fundamentally flawed. For instance, intense radiation from early galaxies could have sterilized small halos, preventing star formation altogether. Or perhaps mergers disrupted Andromeda's satellites long ago, leaving behind only scattered debris. There's even a radical proposal. What if dark matter behaves differently than we think? Some modified gravity theories suggest dark matter halos might not form as abundantly as predicted, meaning fewer dwarfs would exist to begin with. The stakes are high because these satellites aren't just cosmic ornaments, they're critical to testing our theories of galaxy evolution. If dark matter is to blame for their invisibility, it implies the universe is far murkier than we imagined, with galaxies like Andromeda floating in vast seas of unseen structure. But if the models are wrong, it could upend decades of astrophysics, forcing us to rethink how galaxies assemble their cosmic neighborhoods. Interestingly, the Milky Way faces a similar dwarf galaxy shortfall, though to a lesser degree. This parallel deepens the mystery. Is there something unique about how Andromeda interacts with its satellites, or does it reflect a universal gap in our knowledge? Recent surveys have begun uncovering more ultra-faint dwarfs around both galaxies, but the numbers still don't add up. Each discovery peels back another layer, revealing just how much we still don't understand about the cosmos's smallest building blocks. One tantalizing clue comes from simulations showing that many dwarfs might orbit Andromeda in a vast, flattened plane, a configuration that's statistically unlikely if they're randomly scattered. This could suggest they're remnants of a single, ancient collision, a dramatic encounter that left them aligned like pearls on a string. If true, it would mean we're not just missing dwarfs, we might be misreading their history entirely. As telescopes grow more sensitive, the hunt for these phantom galaxies intensifies. Every new detection, or lack thereof, pushes us closer to answering whether the problem lies in the shadows of dark matter or the foundations of our theories. One thing's certain, Andromeda's missing satellites aren't just a counting error. They're a cosmic riddle that could redefine our place in the universe. And speaking of riddles, our next mystery takes us even deeper into the unknown, where the very fabric of spacetime might be twisting reality itself. Now, let's venture into one of the most daring and mind-bending theories about Andromeda's odd behavior, something that sounds ripped straight from science fiction, but might just hold a kernel of truth. Imagine an invisible thread, thinner than an atom yet denser than a mountain range, stretching across the cosmos, warping space and time around it. This is the cosmic string hypothesis, a radical idea that could explain some of Andromeda's most baffling movements. Cosmic strings are theoretical cracks in the fabric of spacetime, thought to have formed in the universe's earliest moments, when reality itself was cooling and settling after the Big Bang. Picture them as cosmic scars, one-dimensional defects where the laws of physics behave differently. Though they've never been directly observed, their potential effects are staggering. A single cosmic string could curve space around it like a gravitational lens, tugging on nearby galaxies or even causing time to dilate. If one lies near Andromeda, it might account for the galaxy's unusual rotation patterns or the odd trajectories of its satellite galaxies. But why is this idea so controversial? For starters, cosmic strings remain purely hypothetical. No telescope has ever captured definitive evidence of their existence, though some researchers argue subtle anomalies in cosmic microwave background radiation. The afterglow of the Big Bang could hint at their presence. Critics counter that these anomalies might stem from more mundane cosmic phenomena, like interstellar dust or measurement errors. There's also the problem of scale. Cosmic strings would need to be unimaginably massive to visibly affect a galaxy as large as Andromeda, yet their proposed width is absurdly tiny. It's like trying to move an ocean by plucking a single guitar string. Proponents of the theory point to peculiarities in Andromeda's motion that standard gravitational models struggle to explain. For example, some of its outer stars appear to orbit in unexpected directions, as if influenced by an unseen linear gravitational field, a hallmark of a cosmic string's pull. Others note that Andromeda and the Milky Way are hurtling toward each other faster than dark matter alone can account for. Could a cosmic string be acting as a gravitational slingshot, accelerating this collision? Skeptics argue that invoking cosmic strings is a last resort, a dramatic solution when simpler explanations, like unseen dark matter clumps or measurement uncertainties, haven't been ruled out. After all, Occam's razor suggests we shouldn't multiply mysteries to solve mysteries, yet history has shown that sometimes the universe favors the exotic. Black holes, once deemed too strange to exist, are now foundational to astrophysics. Could cosmic strings follow the same path? The debate speaks to a larger tension in cosmology. How far should we stretch our theories to fit the data? For now, the cosmic string hypothesis remains on the fringe, a tantalizing what if that challenges our grasp of reality. But as telescopes probe deeper into Andromeda's secrets, we might just find that the truth is stranger than fiction. And if these space-time scars are real, they wouldn't just rewrite Andromeda's story, they'd redefine our understanding of the universe's very architecture. Up next, we'll explore an even more perplexing twist, one where time itself seems to bend in Andromeda's shadow. Now, let's shift our gaze to something even more mind-bending, time itself behaving strangely within Andromeda's depths. Picture this: in certain pockets of the galaxy, clocks might tick slower than they should, as if the universe itself is pressing pause. This is the Andromeda time dilation effect, a phenomenon so bizarre it challenges our very understanding of how time flows in the cosmos. Time dilation isn't science fiction, it's a real consequence of Einstein's theory of relativity. Near massive objects like black holes, gravity warps spacetime so severely that time slows down relative to areas with weaker gravity. But here's the twist: astronomers have detected regions in Andromeda where time appears to drag more than existing models predict. Some speculate this could stem from an unseen supermassive object, like a hidden black hole cluster or a dense knot of dark matter, warping spacetime in ways we can't yet explain. Others wonder if it's an illusion caused by the galaxy's complex motion, with overlapping gravitational fields creating false signals. The debate heats up when you consider the evidence. Observations of certain star clusters in Andromeda show their light reaching us slightly delayed, as if their clocks are running slower than ours. This isn't just a tiny discrepancy. Some calculations suggest the difference could amount to years over cosmic timescales. Skeptics argue these delays might come from interstellar dust or instrumental errors, but proponents counter that the patterns are too consistent to dismiss. Then there's the wild card: quantum physics. A handful of theorists propose that quantum effects, usually negligible on galactic scales, might be amplifying time dilation in Andromeda. Imagine spacetime as a frayed tapestry with tiny quantum fluctuations stitching together in a way that locally twists time. It's a fringe idea, but if true, it would rewrite the rules of both relativity and quantum mechanics. Why does this matter? Time dilation isn't just a curiosity, it's a tool. By studying how time bends in Andromeda, we could map hidden mass, test relativity's limits, or even uncover new physics. But until we untangle observation from artifact, the mystery endures. Is Andromeda hiding a cosmic time warp, or are we seeing the universe's greatest magic trick? Only deeper observations will tell. Up next, we'll spotlight something equally puzzling: glowing infrared objects in Andromeda that defy all known explanations. As we peel back another layer of Andromeda's mysteries, let's turn our attention to something eerily invisible: objects that glow brightly in infrared light but vanish when we look for them in visible light. These unidentified infrared objects are like cosmic ghosts, leaving scientists scratching their heads. What could they be? Failed stars too dim to shine? Dust clouds hiding secrets, or something far more speculative like technology from an advanced civilization? The possibilities are as tantalizing as they are perplexing. Infrared light reveals what our eyes can't see: heat radiating from cool or hidden objects. Normally, celestial bodies emit light across multiple wavelengths, but these anomalies defy the pattern. They blaze in infrared surveys, yet optical telescopes show nothing in the same spots. One leading theory points to brown dwarfs, often called failed stars. These objects lack the mass to ignite nuclear fusion, so they simmer in darkness, emitting only faint infrared warmth. But here's the catch: the infrared signatures in Andromeda are sometimes too intense for typical brown dwarfs. Could they be a new, undiscovered class of these dim objects? Then there's the dust hypothesis. Giant clouds of cosmic dust, warmed by nearby stars or collisions, might glow in infrared without reflecting visible light. Yet some of these objects appear too compact and structured for random dust clouds. A handful of astronomers have floated the idea of protoplanetary disks, dense rings of debris around young stars, but these usually emit some visible light. The absence of any visible counterpart makes these Andromeda objects stand out as true oddities. Now, let's venture into speculative territory. Could these be megastructures like hypothetical Dyson spheres, alien-built energy collectors enveloping stars? While it's a long shot, the idea isn't entirely dismissed. SETI researchers occasionally revisit such anomalies, checking for patterns that might hint at artificial origins. Still, nature is often stranger than fiction. Perhaps the answer lies in a mundane yet undiscovered astrophysical process, like exotic quantum effects in cold molecular clouds. The enigma deepens when we consider their distribution. These objects aren't scattered randomly. Some cluster in specific regions of Andromeda, almost as if they're tied to unseen structures or forces. This clustering fuels theories involving dark matter. Maybe these objects are interacting with invisible halos, heating up in ways we don't yet understand. Alternatively, they could be remnants of ancient galactic mergers with properties altered by violent cosmic events. Why does this matter? Unidentified infrared objects aren't just curiosities. They could hold clues about star formation, galactic evolution, or even the composition of dark matter. Every unexplained glow is a potential doorway to new physics. Until we train more powerful telescopes on Andromeda, these infrared phantoms will keep their secrets, but one day they might rewrite our textbooks. Next, we'll examine another eerie glow around Andromeda, this time in the form of gamma rays, creating a halo that shouldn't exist. But before we move on from those infrared phantoms, let's shift our gaze to another beguiling glow surrounding Andromeda, a faint but persistent gamma ray halo that defies easy explanation. Unlike the Milky Way's more concentrated gamma emissions, This ethereal glow stretches far beyond Andromeda's visible disk, forming a diffuse sphere of high-energy light. What's causing it? The answer might lie in the invisible scaffolding of the universe itself, dark matter. Gamma rays are the universe's most energetic light, often produced by cataclysmic events like supernova or colliding neutron stars. But Andromeda's gamma halo doesn't match those violent sources. Instead, it's smooth and evenly distributed like a cosmic fog. One compelling theory suggests that dark matter particles, those elusive building blocks of the universe, might be annihilating each other in Andromeda's outskirts, converting their mass into gamma rays. If true, this would be our first tangible clue about dark matter's true nature. Imagine particles we've never directly detected, revealing themselves through a faint, high-energy whisper. Yet there's a twist. The Milky Way, Andromeda's galactic twin, doesn't show the same gamma-ray halo, despite presumably having a similar dark matter structure. This discrepancy has scientists puzzled. Could Andromeda's dark matter be denser or more active, or is something else entirely at work? Alternative explanations point to cosmic rays, high-speed particles slamming into interstellar gas, producing gamma rays as they decelerate. But again, the distribution is odd. Cosmic rays typically trace the galaxy's spiral arms, yet Andromeda's halo is uniformly spherical, suggesting a different origin. Then there's the timing. Some researchers argue that Andromeda's violent past, its history of galactic collisions, might have stirred up its dark matter, triggering more frequent annihilations. If so, this halo could be a fossil record of those ancient mergers, a relic of chaos frozen in gamma light. Others propose exotic physics, like decaying hypothetical particles called actions, which could also produce such emissions. The possibilities are as thrilling as they are speculative. Why does this gamma-ray enigma matter? Dark matter makes up nearly 85% of the universe's mass, yet we've never seen it directly. Andromeda's halo could be the key to unlocking its secrets. Every photon carries a clue, and with next-generation telescopes like the Cherenkov telescope array coming online, we might soon have answers. Until then, this faint glow remains one of Andromeda's most tantalizing mysteries, a cosmic fingerprint waiting to be decoded. Up next, we'll delve into an even stranger vanishing act, star clusters in Andromeda that disappear without a trace. Now, let's turn our attention to one of Andromeda's most baffling disappearing act star clusters that simply vanish before our eyes. Unlike the gradual dimming of aging stars, these clusters seem to wink out of existence in mere decades, leaving astronomers scratching their heads. What could make entire groups of stars, often hundreds or thousands strong, disappear without a trace? The answer might reshape our understanding of how star clusters live and die. Star clusters are cosmic nurseries packed with stars born from the same gas cloud, bound together by gravity. They're supposed to be stable, lasting for billions of years. Yet in Andromeda, some clusters have been observed fading dramatically or vanishing entirely over shockingly short timescales. One leading theory suggests they're being torn apart by tidal forces. Picture this: as these clusters orbit Andromeda's center, the galaxy's gravitational pull stretches them like taffy, stripping away stars until the cluster dissolves. But here's the catch: tidal disruption usually takes millions of years, not decades. Why is it happening so fast here? Another possibility is that these clusters aren't actually vanishing but are being obscured by dense clouds of interstellar dust. Andromeda is no stranger to cosmic dust lanes, and if a cluster drifts behind one, it could appear to fade suddenly. However, follow-up observations with infrared telescopes which pierce through dust haven't always found the missing clusters. That leaves us with even stranger explanations. Could these clusters be collapsing inward, their stars merging into a single massive object? Or is there an unseen force, a rogue black hole, perhaps scattering their stars into the void? The most intriguing clue comes from the clusters themselves. Many of these vanishing acts involve faint fuzzy clusters, loose, dim groupings that defy traditional classifications. Some astronomers argue these might not be true star clusters at all but temporary associations of stars, destined to drift apart. Others speculate they could be remnants of dwarf galaxies torn apart by Andromeda's gravity, leaving behind ghostly traces that quickly disperse. What makes this mystery so urgent is that star clusters are cosmic fossils holding clues to galaxy formation. If they can vanish this quickly, our models of galactic evolution might need revising. Upcoming telescopes like the Vera-C Rubin Observatory could finally crack the case, monitoring Andromeda's clusters in unprecedented detail. Until then, these disappearing acts remind us that even the most stable parts of the universe are full of surprises. And speaking of cosmic enigmas, our next phenomenon takes us even deeper into the unknown, a strange pattern of light echoes that defy all expectations. Now, let's step into the realm of cosmic mirages, light echoes from Andromeda that behave like ghostly whispers of long-dead stars. Imagine a supernova exploding so brightly it outshines its entire galaxy, only for its light to bounce off unseen dust clouds and return to us centuries later. These delayed reflections, called light echoes, should follow predictable paths, fading in orderly ways. But in Andromeda, they're breaking all the rules, appearing in bizarre patterns and timelines that leave scientists stunned. Light echoes aren't just pretty glows, they're time capsules. When a star explodes, its light races outward in all directions. Some of it reaches Earth directly, while the rest scatters off interstellar dust, taking a detour before finally arriving. By studying the delay between the initial blast and its echo, astronomers can map the hidden structures of galaxies. Normally, these echoes form neat, expanding rings like ripples in a pond. But in Andromeda, they're more like scattered puzzle pieces. Some flicker to life decades after the supernova faded, while others appear in entirely unexpected corners of the galaxy. One of the biggest head-scratchers is the echo from a supernova observed in Andromeda in the late 19th century. Its light should have faded into obscurity by now, yet modern telescopes keep catching faint, disjointed echoes, some far from where the original explosion occurred. Why? One theory points to Andromeda's unusually clumpy dust distribution. Unlike the Milky Way's smoother interstellar medium, Andromeda's dust might be piled into dense, irregular clouds that refract light in chaotic ways. Picture a hall of mirrors where some reflections take detours through hidden corridors, popping up where you least expect them. But there's a wilder possibility. These echoes might not be from supernova at all. Some researchers suggest they could be caused by rare, hyper-energetic stellar collisions or even eruptions from Andromeda's central black hole. If true, it would mean we're witnessing entirely new astrophysical phenomena masquerading as familiar light echoes. The timing of these echoes is equally baffling. In one case, an echo appeared nearly a century after its presumed source supernova, far too late for conventional models. This has led to speculation that Andromeda's unique gravity might be bending light in ways we don't yet understand, or that multiple explosions are overlapping their echoes in a cosmic game of telephone. What makes this mystery so tantalizing is that light echoes are more than just celestial curiosities, they're tools. By decoding them, we could reconstruct Andromeda's history of stellar explosions, revealing how often stars die in spectacular fashion. Yet their erratic behavior suggests our maps of the galaxy's dust and gas are woefully incomplete. Upcoming missions like the James Webb Space Telescope might finally untangle these riddles, peering through the chaos to reveal the truths hidden in Andromeda's ghostly glows. And just when you think Andromeda can't get any stranger, wait until you hear about the stars within it that defy all expectations, metal-rich oddities that shouldn't exist. Now, let's turn our attention to something even more puzzling: stars in Andromeda that defy the very laws of cosmic chemistry. Picture a star shining with a brilliance that shouldn't be possible, packed with metals far beyond what conventional stellar processes can explain. These are the metal-rich mystery stars of Andromeda, celestial anomalies that have astronomers questioning everything they thought they knew about star formation. First, let's clarify what we mean by metal-rich. In astronomy, any element heavier than hydrogen and helium is considered a metal. Stars typically form from vast clouds of gas, mostly hydrogen, with trace amounts of these heavier elements. Over time, through nuclear fusion and stellar explosions, metals are scattered across the galaxy, enriching future generations of stars. But the metal-rich stars in Andromeda are outliers. Some contain up to 10 times the metal content of our Sun, a composition so extreme it challenges our understanding of how stars are born. So where do these cosmic overachievers come from? One leading theory suggests they're relics of ancient galactic mergers. When galaxies collide, their gas clouds smash together, triggering intense bursts of star formation. If Andromeda devoured smaller galaxies in its past, the chaotic mixing of materials could have spawned stars with unusually high metal concentrations. Imagine blending two different soups. Sometimes you end up with pockets of flavor far stronger than anything in the original recipes, but there's a twist. Some of these metal-rich stars are young, which rules out the merger explanation. If they didn't inherit their metals from ancient galactic collisions, how did they acquire them? This has led to a wilder idea: unknown stellar processes might be at work. For instance, certain stars could be hoarding metals from their surroundings like cosmic magpies, pulling in heavy elements from nearby supernova remnants or even cannibalizing smaller companion stars. Others might be the products of rare, ultra-metal-rich molecular clouds, regions of space where dust and gas have been unusually enriched by countless stellar explosions. The most baffling cases, though, are stars that appear to have formed with their metal overload intact, as if they were born from some exotic, metal-saturated environment unlike anything we've seen. This raises a tantalizing question: could there be undiscovered mechanisms for metal production in stars, processes that bypass the usual supernova and neutron star channels? What makes this mystery so crucial is that metals are the building blocks of planets and life. If stars can form with such extreme metal content, it could mean planetary systems in Andromeda are far stranger than we imagined. Picture worlds with crusts made of platinum or oceans of liquid mercury, landscapes shaped by chemistry we've never encountered. The search for answers is heating up. New telescopes are scrutinizing these stars for clues, analyzing their light to decode their compositions and origins. Some researchers are even proposing that Andromeda's unique history, its violent mergers, its turbulent star-forming regions, might have created conditions impossible in our own Milky Way. And just when you think the cosmos can't surprise us any further, Andromeda delivers yet another enigma, this time in the form of a hydrogen disk twisted into shapes that defy explanation. Now, shifting our gaze to the fringes of Andromeda, we encounter a cosmic distortion so striking it resembles a warped vinyl record, the galaxy's twisted outer hydrogen disk. This vast, gnarled structure, stretching far beyond Andromeda's familiar spiral arms, defies the orderly flatness we expect from galactic disks. So what's bending this colossal sea of hydrogen into such peculiar shapes? Hydrogen, the lightest and most abundant element in the universe, typically settles into thin, rotating disks around galaxies. But Andromeda's outer disk is anything but flat. Instead, it kinks and bends like a crumpled sheet of paper, with entire sections tilted at sharp angles. Some regions even loop back toward the galaxy's center, creating a labyrinth of misaligned gas. This warping is far more extreme than anything seen in the Milky Way, suggesting Andromeda's history is far more turbulent. One leading suspect is gravity, specifically, the gravitational pull of unseen matter. Andromeda is thought to be shrouded in a halo of dark matter, an invisible substance that outweighs its visible stars and gas. If this halo is unevenly distributed, its gravitational tugs could be twisting the hydrogen disk like an unseen hand warping a vinyl record. Alternatively, the culprit might be smaller galaxies that once orbited Andromeda. Over billions of years, their gravity could have tugged at the disk, leaving behind these ghostly distortions like ripples in a pond. But there's another tantalizing possibility: past collisions. Andromeda's violent history of galactic mergers might have sent shockwaves through its outer disk, disrupting its structure. Imagine tossing a stone into a calm lake. The ripples spread outward, changing the surface. Similarly, an ancient smash-up with another galaxy could have sent gravitational ripples through Andromeda's hydrogen, permanently warping its shape. Supporting this, astronomers have spotted streams of stars and gas debris from past mergers woven through Andromeda's outskirts like cosmic scars. What makes this phenomenon so puzzling is its sheer scale. The warped region spans tens of thousands of light-years, dwarfing even the largest known galactic collisions. If gravity alone is responsible, the forces at work must be unimaginably strong. Some researchers propose that multiple factors are at play: dark matter, past mergers, and even ongoing interactions with smaller galaxies, all combining to twist the disk into its current form. The implications stretch beyond Andromeda. Warped disks could be cosmic breadcrumbs revealing a galaxy's hidden past. By studying these distortions, astronomers might uncover clues about dark matter's distribution or the frequency of ancient galactic smash-ups. Andromeda's extreme warping might even hint that our own Milky Way, set to collide with it in 4 billion years, could one day sport similar twists. As telescopes map Andromeda's hydrogen in ever greater detail, each new observation peels back another layer of this mystery. The warped disk stands as a testament to the galaxy's dynamic, chaotic life, a reminder that even the grandest cosmic structures are shaped by forces we're only beginning to understand. And speaking of unseen forces, our next enigma takes us to the heart of Andromeda, where the galaxy's central black hole occasionally erupts in violent, unpredictable flares. Now, let's turn our attention to the very core of Andromeda, where something far more volatile lurks: a supermassive black hole that occasionally explodes with sudden, violent flares. Unlike the steady, almost sleepy activity of our own Milky Way's black hole, Sagittarius, a star, Andromeda's central beast, seems to have a temper, erupting without warning in bursts of energy so intense they can outshine the entire galaxy for brief moments. At the heart of Andromeda sits a monster, a black hole weighing in at around 100 million times the mass of our Sun. Normally, black holes of this size consume matter at a slow, steady pace, glowing faintly as gas spirals into their grasp. But Andromeda's black hole defies expectations. Every few years, telescopes catch it flaring up, blasting out high-energy radiation that spikes dramatically before fading just as quickly. These aren't the gentle flickers seen in our own galactic center. They're full-blown tantrums with energy releases so powerful they rival quasars, the brightest objects in the universe. So why does Andromeda's black hole behave so differently from ours? One theory points to its diet. While Sagittarius, a star, nibbles on sparse clouds of gas, Andromeda's black hole might be feasting on larger, more chaotic meals. Imagine dumping a bucket of water onto a campfire. Some trickles in steadily, producing a calm flame, but a sudden splash causes a burst of steam and sparks. Similarly, if a star or a dense gas cloud veers too close to Andromeda's black hole, the violent disruption could trigger an explosive flare. Astronomers have even spotted stars on erratic orbits near the galaxy's core, suggesting past disruptions that could explain these erratic outbursts. Another possibility involves magnetic fields. As matter swirls toward a black hole, it forms a superheated disk, and tangled magnetic fields within this disk can snap like rubber bands, releasing enormous bursts of energy. In Andromeda, these magnetic explosions might be more frequent or intense due to the way material flows into the black hole. Or perhaps the flares are linked to the galaxy's turbulent past. Mergers with smaller galaxies could have dumped fresh fuel into the center, stirring up the accretion disk and sparking these violent episodes. What's truly puzzling is the randomness of the flares. Unlike predictable volcanic eruptions or solar flares, Andromeda's outbursts seem to follow no clear schedule. One year, the black hole might remain eerily quiet. The next, it could erupt multiple times. This unpredictability makes them both fascinating and frustrating to study. Some researchers speculate that hidden factors, like the alignment of magnetic fields or the presence of unseen companion objects, might act as hidden triggers pulling the strings behind the scenes. Comparing Andromeda's hyperactivity to the Milky Way's calm center raises bigger questions. Is our black hole unusually quiet, or is Andromeda's unusually lively? The answer could reshape our understanding of how supermassive black holes evolve. If Andromeda's flares are a sign of youth or recent feeding frenzies, it might suggest that our own black hole is in a more dormant phase, perhaps biding its time before its next big meal. These flares aren't just cosmic spectacles, they're clues. By studying them, astronomers can probe the extreme physics near black holes, testing theories about gravity, plasma, and energy release in environments we can't replicate on Earth. And with next-generation telescopes set to monitor Andromeda's core in unprecedented detail, we might soon uncover what truly stirs this sleeping giant awake. As we peel back the layers of this mystery, another oddity in Andromeda demands our attention: clusters of stars that appear hauntingly empty, defying everything we know about stellar gatherings. Now, shifting our gaze from the volatile core of Andromeda, we encounter something equally baffling: clusters of stars that defy expectations by being suspiciously empty. These so-called empty globular clusters are cosmic ghost towns, places where astronomers expected to find thousands of stars densely packed together, but instead they stumble upon eerie expanses of near-nothingness. Globular clusters are typically among the most crowded neighborhoods in the universe, spherical swarms of stars bound by gravity, often containing hundreds of thousands, even millions of stars. They're ancient relics, some nearly as old as the universe itself, and they usually shine brightly from the sheer density of their stellar populations. But in Andromeda, several of these clusters appear strangely understaffed. Observations reveal that some contain only a fraction of the stars they should, as if something has been quietly stealing their light over billions of years. So what's causing these clusters to thin out? One leading suspect is dark matter, the invisible glue that holds galaxies together. Normally, globular clusters don't contain much dark matter. Their gravity comes primarily from the stars themselves. But if dark matter were somehow concentrated in these clusters, its gravitational pull could be flinging stars outward, dispersing them like leaves in a cosmic wind. Alternatively, if these clusters formed within massive dark matter halos, the extra gravity might have prevented stars from bunching up as tightly as expected, leaving them unusually sparse. Another possibility points to tidal forces, the relentless tug of Andromeda's gravity. As clusters orbit the galaxy, they pass through regions where the gravitational pull is stronger, stretching and distorting them. Over time, these tidal interactions could strip away stars, scattering them into the galaxy's halo. Think of it like a comet passing too close to the Sun, shedding material with each orbit until it's reduced to a shadow of its former self. Some of Andromeda's globular clusters may be suffering a similar fate, slowly being dismantled by the galaxy's immense gravitational field. There's also the chance that these clusters never were as dense as their counterparts to begin with. Perhaps they formed differently, emerging from gas clouds that were less concentrated, resulting in fewer stars from the start. Or maybe they're the remnants of disrupted dwarf galaxies, their stars already scattered before they became part of Andromeda's cluster collection. What makes this mystery particularly intriguing is that these empty clusters aren't just oddities, they're potential keys to understanding how globular clusters evolve. If dark matter is the culprit, it challenges the long-held assumption that these clusters are mostly free of it. if tidal forces are to blame, it reveals just how destructive a galaxy's gravity can be over cosmic timescales. And if their sparseness is innate, it forces us to reconsider how such clusters form in the first place. As we continue to study these ghostly gatherings, another enigma awaits: peculiar geometric patterns in Andromeda's stars that some speculate could be signs of something even more extraordinary. Now, moving from the ghostly voids of Andromeda's empty clusters, we turn our attention to something that sparks both curiosity and controversy: an unusual, almost too perfect arrangement of stars that has led some to wonder if we're looking at nature's handiwork or something else entirely. Dubbed the Andromeda megastructure candidate, this peculiar formation stands out like a cosmic fingerprint, its geometric precision raising eyebrows across the scientific community. At first glance, the pattern appears almost deliberate, a near-symmetrical alignment of stars that seems too orderly to be random. Some researchers have even floated the idea that it could be an artificial construct, a signature of advanced extraterrestrial engineering. After all, the concept of megastructures isn't new in astrophysics. Theoretical constructs like Dyson spheres, hypothetical energy harvesting shells built around stars, or vast stellar arrays have been debated for decades. Could this be evidence of such a project on a galactic scale? But before we leap to otherworldly conclusions, let's consider the natural explanations. One compelling theory suggests that gravitational lensing, the bending of light by massive objects, could be distorting our view, creating the illusion of a geometric pattern where none truly exists. Andromeda's immense gravity might be warping the light from background stars, painting a deceptive picture of order amid chaos. Alternatively, the pattern could stem from a rare but natural stellar phenomenon, like the aftermath of a galactic collision that sculpted stars into an unusual configuration. Skeptics point out that nature is full of coincidences that mimic design. Think of the hexagonal storm on Saturn or the near-perfect circles of galactic ring structures that look engineered but are entirely natural. The universe has a way of creating patterns through chaos, whether through gravitational interactions, magnetic fields, or sheer statistical probability. Given the sheer number of stars in Andromeda, it's almost inevitable that some groupings will appear oddly arranged by chance alone. Yet, even the most grounded scientists admit this structure is weird. Its symmetry is striking, and while natural processes can explain it, they don't entirely dismiss the lingering "what if?" That tension between skepticism and wonder is what makes this phenomenon so fascinating. It challenges us to question our assumptions about how structures form, what's possible in nature, and even how we might recognize signs of intelligence beyond Earth. Whether natural or not, this megastructure candidate serves as a reminder that Andromeda still holds puzzles that defy easy answers. And as we peel back its layers, we're left with yet another mystery, one that leads us to the next enigma: the repeating fast radio bursts that echo from this galaxy's depths. But now, let's tune into a different kind of cosmic signal, one that crackles across space with bursts of energy so intense they've baffled scientists for years. From the depths of Andromeda, astronomers have detected something extraordinary: repeating fast radio bursts, or FRB, that pulse at irregular, unpredictable intervals. Unlike the one-off blips we've observed elsewhere, these signals come back again and again, like a cosmic Morse code with no clear sender. Fast radio bursts aren't unique to Andromeda. Our own Milky Way has recorded a handful. But there's something peculiar about the ones emanating from our galactic neighbor. For starters, their repetition defies the norm. Most FRBs are singular events, vanishing as quickly as they appear, leaving astronomers scrambling for explanations. Yet Andromeda's repeating bursts follow no discernible pattern, flaring up at random, sometimes falling silent for months before crackling back to life. This inconsistency makes them even harder to pin down. One leading theory points to magnetar's highly magnetic neutron stars born from the violent deaths of massive stars. These cosmic powerhouses can unleash bursts of energy strong enough to outshine entire galaxies for milliseconds. In the Milky Way, we've linked at least one FRB to a magnetar's outburst, but Andromeda's repeating signals don't quite match the profile. Their energy levels and irregular timing suggest something more complex, perhaps a magnetar tangled in a dense debris field or interacting with an unseen companion. Then, of course, there's the elephant in the room. Could these be artificial? The idea isn't as far-fetched as it sounds. FRBs are precisely the kind of signal a technologically advanced civilization might produce, whether as propulsion byproducts, communication attempts, or even cosmic lighthouses. The irregular repetition could hint at intentional design, a message meant to stand out against nature's noise. But before we jump to extraterrestrial conclusions, it's worth noting that nature excels at creating phenomena that mimic intelligence. Pulsars, for example, were once nicknamed LGM, or Little Green Men, for their clock-like precision before their true nature was understood. What truly sets Andromeda's FRBs apart is their context. Unlike the Milky Way's bursts, which often originate in star-forming regions, Andromeda's signals come from quieter, older stellar neighborhoods. This discrepancy raises questions about whether environment plays a role in their formation, or if we're seeing an entirely new class of FRBs. The mystery deepens when we consider that no two repeating bursts behave exactly alike, as if each has its own personality. So what's really going on? For now, Andromeda's FRBs remain an open question, a reminder that even the most advanced telescopes can't always decode the universe's quirks. Whether they're the cries of magnetars, the artifacts of alien engineering, or something we haven't even imagined yet, these bursts are a tantalizing puzzle. And as we listen to their erratic whispers, we're led to another enigma, one that lurks in the faint, ghostly glow of gamma-ray jets, stretching far beyond where our eyes can see. Now, shifting our gaze from the erratic whispers of radio bursts, we encounter something even more elusive, the ghostly gamma-ray jets radiating from Andromeda's core. Unlike the brilliant, high-energy beams we typically associate with supermassive black holes, these jets are faint, off-axis, and almost spectral in nature. Detecting them has been like trying to spot a candle flickering in a foggy night, and yet their very existence challenges what we thought we knew about cosmic jet physics. Gamma rays are the universe's most energetic light, born from the most violent processes imaginable: black hole feasts, neutron star collisions, or the annihilation of matter. Normally, when a supermassive black hole like the one at Andromeda's heart devours surrounding gas, it blasts twin jets of particles at near light speed, glowing fiercely in gamma rays along our line of sight. But Andromeda's jets are different. They're tilted away from us, their light stretched thin and diluted, making them far harder to spot than the head-on blasts we see in other galaxies. It's like catching the glow of a lighthouse from the side, its beams still powerful, but its light scattering into the void before reaching us. So why are these off-axis jets so significant? For one, they suggest that black hole activity in Andromeda might be more widespread than we realized. Most galaxies' jets are detected only when pointed directly at Earth, meaning we could be missing countless others angled away from us. Andromeda's faint gamma glow hints that quiet, off-kilter black holes could be far more common than our telescopes have revealed. Even more intriguing, the structure of these jets defies some long-held assumptions. Typically, jets are thought to be narrow, focused streams, but Andromeda's appear broader and more chaotic, possibly due to interactions with surrounding gas or magnetic fields. This could mean that the environment around a black hole plays a bigger role in shaping its outbursts than we've accounted for. Then there's the mystery of their intermittency. Unlike the steady gamma-ray glow from other galaxies, Andromeda's jets seem to flicker, flaring up and dimming in irregular cycles. Some astronomers propose this could be due to the black hole hiccuping as it consumes matter in fits and starts, while others suspect magnetic instabilities in the jet itself. kinking and twisting like a garden hose with too much pressure. Whatever the cause, this variability adds another layer of complexity to our understanding of how black holes channel energy into space. Perhaps the most tantalizing clue these ghostly jets offer lies in their composition. Gamma rays are often produced when fast-moving particles slam into photons or other matter, but Andromeda's off-axis jets seem to carry an unusual mix of particles, including positrons, the antimatter counterparts to electrons. This raises the question, could these jets be a hidden source of antimatter in the universe? And if so, what does that mean for the balance of matter and antimatter in the cosmos? As we piece together the puzzle of these faint, tilted beams, one thing is clear: Andromeda's gamma-ray jets are more than just a cosmic curiosity. They're a window into the hidden mechanics of black holes, revealing the subtle ways these monsters shape their surroundings. And just beyond their faint glow, another enigma beckons: the possibility of a rogue supermassive black hole drifting unchained through Andromeda's halo, untethered to any galaxy center. But that's a story for another moment. But what if Andromeda's most terrifying predator isn't anchored at its center at all? Moving beyond the ghostly jets, we now turn our attention to a cosmic drifter, a rogue supermassive black hole possibly lurking in the galaxy's outer reaches. Unlike the well-behaved black holes that sit obediently in galactic cores, this one appears to be a wanderer, untethered and free-floating through Andromeda's halo. The idea alone is enough to send a shiver down any astronomer's spine. How does a black hole of such staggering scale, weighing in at millions of times the mass of our Sun, end up adrift in the cosmic void? The leading theory points to a violent galactic collision. When two galaxies merge, their central black holes eventually spiral toward each other, locked in a gravitational dance. But sometimes, if the merger is lopsided or chaotic, the kickback from gravitational waves can fling one of the black holes outward like a slingshot, sending it careening into the galactic outskirts. Given Andromeda's history of violent mergers, this scenario isn't just plausible, it's likely. Now, imagine a black hole of that magnitude drifting unnoticed through a sea of stars. Could it pose a threat? The answer is a cautious yes, but not in the way you might think. Unlike the apocalyptic scenarios of sci-fi movies, this rogue isn't actively eating stars or planets. Instead, its danger lies in its gravity. As it moves, its immense pull could disrupt the orbits of nearby stars, sending them spiraling unpredictably or even ejecting them from the galaxy entirely. Think of it as a bull in a cosmic china shop. It doesn't mean to cause chaos, but its sheer presence reshapes everything around it. What makes this wandering giant even more fascinating is the way we detect it. Without the telltale glow of an accretion disk, the swirling ring of superheated gas that typically betrays a black hole's presence, astronomers must rely on indirect clues. For example, stars in its vicinity might exhibit unusual high-speed motions, as if something massive but invisible were tugging at them. Alternatively, gravitational lensing, where the black hole's gravity bends light from background stars, could reveal its presence like a shadow passing over a distant lantern. The implications of a rogue supermassive black hole extend far beyond Andromeda. If these drifters are common, they could rewrite our understanding of galaxy evolution. For instance, could they be the seeds of ultra-compact dwarf galaxies? Might they explain odd star clusters that seem too dense for conventional models? And perhaps most unsettling, could one ever drift into our own galactic neighborhood? While the odds are astronomically low, the mere possibility reminds us that the cosmos is far wilder than we often assume. As we ponder this cosmic nomad, another mystery demands our attention, one that twists the very fabric of Andromeda's structure. Beyond the halo's dark wanderer lies an even more perplexing sight: dust lanes that defy logic, twisting in directions no model predicted. But that unraveling waits just ahead. But if a rogue black hole wasn't strange enough, Andromeda has another bewildering feature up its sleeve: dust lanes that twist and turn in ways that baffle astronomers. These aren't your typical cosmic dust trails. Instead of following predictable paths, they snake through space in impossible directions, defying every model we have for how interstellar dust should behave. Picture trying to map a river that suddenly flows uphill or branches in jagged, unnatural angles. That's the kind of cosmic head-scratcher we're dealing with here. So what's causing these rebellious dust lanes? One leading theory points to magnetic fields, invisible lines of force that permeate galaxies. Under normal circumstances, dust particles align with these fields, creating orderly, thread-like structures. But in Andromeda, something is throwing this system into chaos. The dust isn't just misaligned, it's contorted into shapes that suggest the magnetic fields themselves might be tangled or distorted. Imagine trying to comb a head of hair where the strands suddenly knot themselves against the direction of the brush. That's the level of confusion these dust lanes introduce. Another possibility is the influence of unseen matter, dark matter, or even remnants of past galactic collisions. If invisible mass is warping the fabric of space around these dust lanes, it could twist them into their strange configurations. Think of it like a hidden hand pressing down on a cosmic sheet, causing wrinkles that pull the dust in unexpected ways. The challenge is that we can't directly observe this dark matter, so astronomers have to play detective, piecing together clues from the dust's bizarre movements. What makes this mystery even more frustrating is that dust lanes are supposed to be one of the simpler features of a galaxy. In most cases, they follow the rotation of the galaxy or the pull of its spiral arms. But Andromeda's dust lanes seem to operate by their own rules. Some sections appear to move against the galaxy's spin, while others loop back on themselves like cosmic pretzels. It's as if the galaxy's rulebook got tossed out the window and no one told the dust. The implications here stretch beyond just Andromeda. If our models can't explain these dust lanes, what else might we be missing about how galaxies evolve? Could similar twists exist in the Milky Way, hidden in plain sight? And if magnetic fields or dark matter are truly behind this, it forces us to reconsider how these forces interact with visible matter on a galactic scale. Every time we think we've figured out the rules of the cosmos, Andromeda throws us another curveball. Yet even as we grapple with these tangled dust lanes, another oddity waits in the wings, one that suggests Andromeda might be holding up a mirror to our own galaxy. But that revelation is just ahead. Now here's something that might make you do a double take. As we near the end of our journey through Andromeda's strangest phenomena, we stumble upon an eerie cosmic quirk. Certain features of this galaxy look like they were copied and pasted from our own Milky Way. Scientists call it the Andromeda mirror effect, and it's as puzzling as it is mesmerizing. Imagine looking at a distant cousin and realizing they have your exact smile, your same gestures, except in this case, the cousin is 2.5 million light-years away, and the smile is a collection of stars, dust, and galactic structures that seem to match ours in uncanny ways. Take the spiral arms, for example. Both galaxies are grand spirals, but beyond that basic similarity, astronomers have noticed peculiar alignments in how their arms curve, where star-forming regions cluster, even how their central bulges are structured. It's not just a vague resemblance, it's like two dancers moving in sync across the universe. Then there's the distribution of globular clusters, those dense pockets of ancient stars. In both galaxies, they're arranged in similar halos with comparable numbers and spacing. Even the chemical fingerprints of stars in certain regions match more closely than you'd expect from random chance. So is this just a fluke, or is there something deeper at play? One camp argues it's pure coincidence after all. With billions of galaxies in the observable universe, some are bound to look alike. But others think the mirror effect hints at shared origins or universal rules we don't yet understand. maybe the same forces that shaped the Milky Way also sculpted Andromeda, like two potters working from the same blueprint. Or perhaps long ago, both galaxies were influenced by the same cosmic environment, a vast web of dark matter or primordial gas clouds that nudged them toward similar evolutions. The most tantalizing theory that the Milky Way and Andromeda are products of a larger pattern, a kind of galactic DNA that repeats across the universe. Just as snowflakes share a hexagonal structure despite their infinite variations, maybe galaxies, too, follow hidden templates. If true, it would mean the universe has a preferred way of building spirals, one we're only beginning to decode. Of course, the irony is hard to ignore. In about 4 billion years, these mirror image galaxies will collide, merging into a single hybrid galaxy. Will the symmetry survive the collision, or will it be lost in the cosmic shuffle? For now, the mirror effect remains one of Andromeda's most poetic mysteries, a reminder that even across vast distances, the universe might still be whispering the same secrets to all who care to look. And with that, we've reached the end of our tour through 25 of Andromeda's strangest wonders. But before we go, let's take one last moment to marvel at just how much we've uncovered and how much still waits to be discovered. If these mysteries sparked your curiosity, don't forget to like this video, subscribe for more deep dives into the cosmos, and hit the bell so you never miss an update. The universe is full of enigmas, and together we'll keep unraveling them one galaxy at a time. Until next time, keep looking up. From swirling paradoxes to ghostly echoes of light, the Andromeda Galaxy has proven itself a treasure trove of cosmic oddities that defy easy explanation. Over this journey, we've uncovered 25 of its most baffling enigmas, from stars racing fast enough to escape their own galaxy, to invisible spiral arms that whisper of violent mergers long past. Each mystery peels back another layer, revealing just how much we still don't understand about our galactic neighbor. Take the Andromeda Paradox, where parts of the galaxy spin backward like a cosmic rebellion. Or the missing dark matter halo, which should be there, but isn't. Then there's that eerie radio ring, a perfect loop of energy with no clear origin, and the sudden X-ray bursts from the core, flashing like a Morse code we can't decipher. And who could forget the hypervelocity stars rocketing through space as if chased by some unseen force? These aren't just quirks, they're cosmic breadcrumbs pointing toward gaps in our knowledge of how galaxies live, evolve, and sometimes break the rules. Yet for every answer we might one day find, Andromeda seems to conjure 10 new questions. Why does time appear to slow in certain regions? What carved those warped hydrogen disks into twisted shapes? And could that geometric megastructure really be natural or something else entirely? The more we learn, the clearer it becomes. Andromeda isn't just a mirror of our Milky Way. It's a funhouse mirror, distorting our expectations at every turn. So tonight, if the sky is clear, step outside and find that faint smudge of light in the constellation Andromeda. It's more than just a distant spiral, it's a reminder that the universe thrives on mystery. Which of these phenomena captivates you the most? Is it the rogue black hole wandering the halo, or the stars that vanish without a trace? Drop your thoughts in the comments below. We'd love to hear which cosmic riddle pulls at your curiosity. And if you've enjoyed this cosmic deep dive, don't forget to like and subscribe. The universe is vast and we're just getting started. Until next time, keep your eyes on the skies, because out there in the velvet dark, Andromeda is still spinning its secrets.